Now let's move on to average velocity, and actually we'll talk about instantaneous velocity as well. But average velocity is really our velocity over some time interval. So if you were to have traveled for an hour and you traveled 30 miles in that hour, your average velocity was 30 miles per hour. Although there might be a sign associated with that depending on what direction you were headed. Okay. Now, I want to actually write down the definition for average velocity before we even look at this picture. Okay. So average velocity this is equal to the change in position over the change in time. Right? Isn't this how we usually describe speed, at least? You know, a change in position over a change in time. So that's all average velocity is. But in the picture up above, S of t is actually a position function. So we could rewrite this a little bit. How about S of t1 minus S of t2 all over, or actually let's call that t naught. I like that idea better. All over t1 minus t naught. Okay. And the connection I want you to make now is, now that we know S is a position function, and you see this little formula here, you might note that, well, our average velocity is just the same thing as the slope of our secant line. All right, now we want to take our idea of average velocity and shrink the time interval down. Okay. In fact, most of the time when you do think about speed or velocity, you're usually actually thinking about instantaneous velocity, right? When you look at your speedometer, you don't want to know how fast, how fast you've been traveling over the last 30 minutes. You want to know how fast you're traveling right now. Okay. And so we're going to define that. We have instantaneous velocity. Okay. And this is equal to, can you guess? Okay. If we want to know it at a single instant, we'll use the tangent line. Okay, we'll find the slope of the tangent line. So the main thing I want us to take away from this is that instantaneous velocity is the velocity at an instant in time. Okay, and the average velocity is associated with a time interval. Keyword interval. All right, let's move down here a little bit. Okay, so a rock is launched vertically upward from the ground with a speed of 96 feet per second, neglecting air resistance, a well-known formula from physics. So if any of you have had physics, you probably have seen lots of equations that look like this. Okay, and if you're going to take physics, you will see lots that look like this. And this thing states that the position of the rock after t seconds is given by the function, okay? And s equals 0 would correspond to the ground. Okay? And so what we're going to do is really try and actually figure out what the instantaneous velocity is when t equals 1. Okay? But in order to do that, we're going to start off by looking at the slope of the secant line from 1 to 2, and then 1 to 1.5, 1 to 1.1, 1 to 1.01, and we're going to keep shrinking that interval down until we can make a decent guess at what the instantaneous velocity is. Okay. And so we are going to switch to our calculator here. That should help us out a little bit. Now I want to show you all a quick and easy way to fill out that table we have. Coming up with the slope of all those secant lines will be a little easier than you think. Okay. So here's the trick. We're going to go into our y equals, okay, and then we're going to plug in our function for position minus 16, and we don't have t on here. Well, we kind of do, but when we're in function mode, we have to use x. So we're going to have x squared and then plus 96x. Okay. And then if we hit second quit and come back to the main screen here, now that you have that function in there, we can actually use it. So I'm going to hit parenthesis. I'm going to hit vars. I'm going to hit right to y vars, and then I'm on function here, and I'm going to hit enter, and then I'm going to hit enter one more time. And so now I can use the function that I have for y1. So I'm going to plug 2 into it, because if you remember, our first interval on our table was from 1 to 2. So I'm going to plug in 2, and then I'm going to do the same thing, vars, y vars, function, y1, and then I'll plug in 1, and then this is all divided by 2 minus 1. Okay. And this is a lot easier than having to type in minus 16 times 2 squared plus 96 times 2 minus negative 16 times 1 squared minus 96 times 1 all over 2 minus 1. Right? This is a little bit easier. Okay. So we'll hit enter, see what we get, 48. Okay. And now if we want to go a little bit further, we can hit second enter. Ooh. I'm going to try that one more time. Enter, there we go. Second enter is how you get this to pop up. And now if I scroll back, I can change some of these numbers a little bit. So for instance, on my next interval, I want to do 1 to 1.5. So I'm going to change this 2 here. I'm hovering over it. I'm going to hit 1, and then I'm going to hit second insert 0.5. So now it's 1.5 there. I'm going to come over and do that same thing to this 2. And I'm going to use that second insert feature again once I get rid of the 2. There we go. So deleting the 2, and then I'm going to hit second insert, and I want 1.5 there. Okay. Right now it's 56. And then after 1.5, we're now going to do 1.1. Okay. And our goal is to see if, as we shrink this interval down, I think I went a little bit too far there, But as we shrink this interval down, is this ratio approaching anything? There we go. I must have made a little error here. And hit go to and see what it is. Oh, I'm missing my parenthesis over here now. All right, there we go. And let's try a couple more of these. And next we are going to make this 0.01. Okay. And as of right now, it's not clear whether it's approaching anything at all. And it doesn't actually have to approach a number. Okay. I keep going too far on this calculator. There we go. Second, insert, put a 0 there, enter. So now the difference is starting to shrink a little bit. So we have 63.84 there now. Let's add in another 0. Second, insert. There we go. 63.984. And I'm going to do one more. So second, insert. 0 there. There we go. And you can see it just added another 9 there. And so you could imagine now, every time we add another 0, this is going to have another 9 here. So this is going to get closer and closer and closer and closer to 64. Okay. I do want to say what we've done here isn't actually proof that this is going to approach 64. But we have good reason to believe that it's going to. Okay, but we will not too long from now, we will have a way where we can actually prove that this is going to approach 64. All right, I've skipped a little bit ahead here, and I've already filled out the table. Again, the table's kind of nice. It helps us see that this thing is approaching 64. I should be a little bit careful with my wording because, again, you know, this technically isn't proof, but we will figure out a way here in not too long that we can actually use to verify that this is approaching 64. But for now, as a conjecture, we think that this thing is approaching 64, and the units were feet per second.